right, ladies and gentlemen, today it looks like the following. Here are our goals. Number 1, be more like Mike. Number 2, review graphical vector addition so you feel ready, like you know what's going to be on the quiz tomorrow. And number 3, do trig. And it usually takes me about a half an hour to 40 minutes to go cover trig, even if you've never, ever done any trig whatsoever before. I explained it from the ground up. Even if you're like, oh, it was terrible at trig. Okay, then just wipe your brain, pretend it never happened, and we'll move from there. All right. So the first part of this, like I said, is just going to literally show you exactly what type of questions are on the quiz tomorrow. It's not meant to take you the entire time to do the quiz. As we've stated before, you can redo this quiz. You can come in. I will probably even let you take the quiz home the second, third, fourth, however many times you need to get good at it. Okay, whatever it takes. All right, so let me grab my numbers here. Here is exactly what number 1 is going to look like. Number 1 is going to be a vector, something like this. It'll say -6 meters per second squared at -40 degrees from the negative y-axis. And it will tell you to draw that vector as well as tell me what that is in the standard angle so that I know that you guys understand it. This is literally what we did, I think, on Thursday. Okay, so real quick showing you that in case you are struggling with it, here it is. The order that you want to tackle these in is where to measure from, negative y-axis. Okay, then you go to the angle. 40 would go clockwise, so it would go right here, but that's -40. So, sorry, I said that backwards. 40 would go counterclockwise, which is right here. But 40 goes clockwise, so we're going to cut 40 degrees this way. If this was just positive, we would be done. Okay? Since it says a negative up there, we flip it the opposite of that angle. So this is the picture that you should draw. And the standard angle, if that's 40, then that's 40. And the standard angle measures down here. So this would be 6 meters per second squared at 50 degrees. That was very quick, but essentially I wouldn't expect you to be able to necessarily do it that fast. But that's what I would be looking for. Once again, start from the negative y, cut clockwise, in this case 40 degrees, go the opposite way because it's a negative magnitude, and then be able to tell me the standard method, which is from the x going counterclockwise to a positive magnitude, so 6 meters per second at 50 degrees. Give me a fist of 5, how well you think you'll do on this tomorrow. Cool beans, problem number 2. Problem number 2 will be this. I will put up a vector like 20 meters at 200 degrees. Where does that go? What quadrant is that in?
The third.
That is in the 3rd quadrant, probably somewhere like right over here. Yes? Okay, that's 0, that's 90, that's 180, so guess what that is right there? What's that? No, sorry, just right here. It'd be 20 in that case, right? A little bit left over. And then I would say, all right, let's go ahead and write that vector 3 more ways, making sure to either to change where it's measured from, use a negative angle, and use negative magnitude somewhere on there. Now you can mix and match those as much as you want. There's a bunch of right answers, but here's what I would be looking for here. Okay, you could of course say 20 meters at -160 degrees. That is just that angle right there. I could also say that is, sorry, my apologies. I could say 20 meters at, like we said a second ago, 20 degrees from the negative x-axis. That's the same thing. I could also say -20 meters from 20 degrees. Because 20 degrees over there would be positive, so negative flips it, so it goes the exact same way. Those would be the 3 vectors, or something like it. You could do a combination therein. Another one you could do here that combines both of them is you could say 20 meters at, say, negative, I don't know why I keep using equals, at -70 degrees from the negative y-axis. That would just be cutting from here, 70 degrees over. Fist of 5, how you feel about that one? Cool beans, moving on. Next. I'll give you a couple of vectors like this. I'll say, hey, this is A, and this is B. Show me what A plus B looks like. Okay? In which case you would draw A, and where would I draw B from there? From the end of it, right, B. And then just make sure that, of course, you show the solution. This resultant vector would be A plus B. And then I would also probably just check to make sure you understand subtraction, aka what is b minus a? Now, b minus a is essentially b plus a negative a. So all you would do here is you draw b, here's b. And now what am I going to do instead of drawing a? A was up in the second quadrant, so what do I draw? Down in the fourth quadrant, there's negative a right there, and this would be b minus a. Fist to 5 on that. Cool. Seems like we're going pretty well so far. This last one I'm actually going to have you do, so for anybody who wasn't here on Friday, I have a video I made this morning and I was having trouble uploading, and I finally got it uploaded. But while you guys are working in just a second, I'll make sure that it's actually the link is posted for you, so you can see almost exactly what I did on Friday. I basically just did just one, which we're also going to do in a second. So it's very possible you watch what I'm going to do in a second, and you're like, yeah, I don't need that, but it will also be posted as well. Yes, sir.
Are all the videos posted on the stream? Is it like one collective YouTube channel?
Sometimes it's on, well, it's usually either on the stream when I say that, or oftentimes I will usually put it both on the stream as well as on the assignment itself. So like under Graphical Vector Addition, there will now be a link that says this is a video on how to do Graphical Vector Addition. So usually for you, you can check either, but you can always go to the problems itself and see if there is a video, it should be posted there. All right, so let's do this. I'm going to give you 3 vectors, and I'm going to see what you guys can't do to add this yourself. So here they are, 70 meters per second at negative 30 degrees, negative 28 meters per second at 60 degrees, and 14 meters per second at 0 degrees. Would you like me to put the answer up ahead of time, or would you be worried about spoilers?
Spoilers.
Spoilers. We'll mix and match. When you get done and you need it, you let me know. It'll be out. But I need you to look like more of a sourpuss. You look too happy. Just be kind of like angry about life, because it's, we're physics, obviously. You gotta be pissed off. All right. Just a gentle reminder, if you are doing, is anybody planning on doing pumpkin chunking? Okay, those write-ups are due tomorrow. Okay, so remember, there's not much on the write-up. It'll take you like 5 minutes to sit down with your partner or yourself and do. It's a very quick thing. Make sure you look at it online. It's just a quick sketch. I think it's like a general layout. It's mostly so that we know who to expect to be there, as well as that we know that people at 2 weeks out are doing something of a decent plan, because the launch will be in 2 weeks. So you've had 2 weeks already. So. It's a different kind of.
Exactly.
Alright, the video is posted. I will continue to live my life the same way.
Well, straight out, you're still nice.
What would you have me do differently?
You know that.
You think I should
Like,
just
too
sit
much
down and put
generous.
sackcloth on my back and mourn my life?
That would be
life is
really,
over
that
now?
would be really considerate.
Oh, woe is me!
Thank you.
Even did not get the problem right in physics class. Life is over.
Get me away from that.
I'll be here.
I'm so strong. Really? What did you say? I'm so strong. No, that's not it. Okay. What's the next one? What, I did that this way? Or did you divide it this way? I divided by
Sorry,
7.
people online. This is not a very enjoyable part of this. We should be good in like 3-4 minutes if you want to come back. Hold up. That's for anybody that was watching the video. Sorry, chat.
All right, moving on.
Wait, no.
I'm gonna go over it. If you don't need me, then don't pay attention to me. Fine. This is for anybody that wasn't here on Friday and needs kind of like, how do I even know where to start? Okay, the first thing I like to do, you do not have to do, is I like to sketch roughly where it is. Okay, if you can do that A and B thing that we talked about a second ago, you have a rough idea of where these things are. 70 meters per second at -30 should be in what quadrant?
Oh, wait. Okay, 74.
You are correct. Just write down over here. Yes? Okay? Now, this -28 at 60 degrees, what does the negative do? Someone remind me? Flip it. So what I honestly usually do is I usually set my 60 and then just go the opposite way. Now, if you don't want to do that, you can certainly just see that you add 180 and you get 240, but that should be over here in the third quadrant. Okay? And then finally, 0 degrees goes straight right in this particular spot. So you can see from my kind of crappy sketch in this case that I should kind of be going down and right in general here. So I'm certainly not starting in the middle or starting on the right side of my page. That seems like a bad move. All right, so that's starting off with what you might do. Well, here's what you have to do. The first thing you have to do on your page is scale. Okay, for those of you that weren't here Friday, there's about 21 centimeters across on a standard page. This depends on your notebook, it might be a little bit different. Up and down, there's probably something like 28 to 30 centimeters. Again, kind of depending on the page, but that is the general ratio. So know that your lines obviously have to kind of fit there. Now, what I suggest is you don't want to make your scale so big that it makes the thing really tiny, because then small mistakes will be magnified. I think a good rule of thumb is that like your biggest line should probably be somewhere between about 10 and 15 centimeters-ish. So like if I was doing this and seeing everything pretty evenly divisible by 7, if I was on your page, I would probably use a scale of something like 7 to 1. Okay, so if I were you, I would say 7 meters per second equals 1 centimeter. Since I'm me and I need to fit it up here on the board, I'm going to say 7 centimeters is 4 centimeters, although that's kind of a weird, dumb ratio. And it's just so that I can make my numbers about 4 times bigger. After you make the scale, you need to figure out what all of these magnitudes are. So the first time you do it, you want to actually do the work. You show the unit conversion. So here's me going 70 meters per second. And I have that 7 meters per second is 4 centimeters. So that's 10 times 4 is, there's 40 centimeters. So when I draw this first vector, I'm going to draw it 40 centimeters long to represent it. And I need to do the same thing for all the rest of these. Again, you don't need to show the work for all of them. You just need to show the work once, and then you can do the same thing for the rest of them. So here that would be, what, 16 centimeters, I think, and this would be 8 centimeters for me. Obviously, that's not going to be the same for you. If you did my suggestion of 7 to 1, then you would be at a, what would it be? You'd be 10, 4, and 2. Of course, you don't have to use that ratio. A very popular ratio that some people like is just 10 to 1, because you can just move the decimal. If you have 10 to 1, then that would be a 7 centimeters, that would be 2.8 centimeters, and that would be 1.4. But again, as your vectors get small like that, be careful, because small mistakes matter that much more. All right. Now the actual process. Here we go. Sorry, that was very Mario with me. Okay. Lay out an XY axis. The main purpose of the XY axis is to lay a spot for your protractor. For the first vector, all you're going to do is set the angle. 30 degrees is going to come right down here. Keep in mind that your protractor is a dumb piece of plastic. You have to know where negative 30 degrees is. Okay? So sometimes people ask me, do I use the numbers on the inside or the numbers on the outside? I don't know. It depends on how you set up your thing and where it is. So you have to know where the correct angle is supposed to go. The protractor's not going to tell you. Okay? We have to know that negative 30 goes down in the fourth quadrant. Once you've set your angle with your protractor by drawing this line here, any line you draw from the origin to that will be at negative 30 from there. I know that I need to draw my line 40 centimeters long. If you did the ratio I suggested on your page, of course, you would be at 10 centimeters long. Just making it bigger for me so that you can see it better. Drawing an arrow is absolutely required. I do suggest that you maybe label this vector. I'm just going to call this vector A. It'll help me. And more importantly, it'll probably help you to keep track of what's where. I'll just go along and call that B and that's C. Once you've drawn your first vector, you essentially reset the XY axis. It's nice for you that you have lined paper so that you can make sure that these lines are perfectly horizontal or as close to horizontal on your page. But again, I've reset the XY axis so that I can draw my protractor here. Again, like I said a second ago, negative 28 at 60 is 240, so we should be right down here. But me personally, what I actually like with doing a negative vector is I usually just set the 60 and I just draw it in the opposite direction. So instead of come up this way for 60 degrees, I simply line up the origin, line up the line like normal, and then draw 16 centimeters this way. Just a heads up, magnitude tenths matter. For those of you guys who were not here Friday, if you miss by a tenth, it will mess up your probably overall result. Okay, so be careful with how careful you are on these. Next, 14 at 0 degrees. You really don't need a protractor for this as long as you make sure as much as possible that it is horizontal. Just make sure you draw a line that is exactly 8 centimeters in that direction. There's A, there's B, and there's C. Once you're done with all the individuals, the final vector or resultant is an arrow that goes straight from the beginning, straight to the end. That's the resultant, that's our total, and that's what we're going to get our final answers off of. You get the angle from that simply by putting your protractor back on the beginning. So here I have, what's that? Isn't that right? Yeah, negative 44-ish. By the way, that does lead me to, once again, your final answer does not have to be in standard. I very much consider negative 44 easier to measure than the 316 to go the other way. So I'm going to leave it at negative 44. As can you. If you want to give me the weirdest, dumbest angle on that you feel comfortable with, feel free. If you want to measure that the angle from here is positive 46, you are welcome to write that this is 46 degrees from the negative y-axis. Finally, how do we get the magnitude? You measure the length of this line. I have 47.8 myself, 47.8 centimeters.
Teachers and students, pardon the interruption. I do have 4 winners for our student best dress for Spirits Day today. It's a doing office for their prize. Ava Harris, Landon Mucci, Malia Edwards, and Noah Davis. Congratulations, students. Noah Davis.
And I got 83.7. The correct answer on this, I believe, is my paper that had all the answers. Did I eat it?
Yes.
That seems unlikely. Fall over here. Oh, there it is. I got it. correct answer is 84.8 meters per second at, sweet, negative 44. Don't forget that you get plus or minus 2 degrees, and you get plus or minus 5%. Again, to get 5%, move the decimal once and divide by 2. So what is that? That's 8.4 divided by 2. You get about 4.2, something like that on either side. So even if you were at like 80, or if you were up at like 85, you're probably doing it pretty decently as long as your angle's off. If you're off by more than that, you probably made a decently significant mistake somewhere that you need to look back on. Fist of 5, your ability to do this tomorrow. Thumbs up. What is that? A 1? I can't do. My frustration. I appreciate you guys have not broken it yet, and maybe I'm gonna say this and you're going to now. But my frustration is when I get the people that are like, I might get a 3.5. Oh, if I wanted to give you a 10-point scale, I would have given you a 10-point scale. Okay? There's a reason why I only do fist of 5. All right, moving on. Hello. Might I be of assistance? What do you need? Who do you want to take a picture? Who did it?
What's her name?
I think it's Tasia. You gonna come do it?
For what?
They want to take your picture. She wants to take your picture. All right, moving on. Let's talk trig. I got 30, 40 minutes here to cover trig on you real quick. Okay. I don't know if that will help, but you do you. Okay. I have 2 triangles here, one inscribed inside of the other. How do these 2 triangles relate? So I watch a lot of Elmo with my youngest. I don't think Elmo would have said that.
Sorry.
How do these 2 triangles relate? They're triangles! It was fantastic. The energy was definitely there. We gotta love it. What's that? Similar. Okay, there's about 3 right answers I'm looking for. That was one of them. That is correct. They are similar. What else are they? The fact that they're similar means like 3 things. Well, 2 things at least.
You don't know.
Yes. There's many right answers. There's certainly right answers. Penguins are birds. That's also a right answer. Doesn't help us that much more. They have the same angles. That is another right answer, and not the one that I was quite looking for yet, but those are very good. What else? Use a different word. Use a different R word, and I'm cool. Ratio. There it is. That's the magic word that matters the most. Okay? All of the ratios of size are exactly the same. Okay? If I tell you that this guy on the bottom is a 3, 4, 5 triangle, okay? And then I tell you something at all about the bigger triangle, like let's say I tell you that that far right side is 6. What do you now know?
I'm sorry.
Okay, you know that that side is 6. What do you now know? Sure, it's 1 to 2, and therefore?
That side's 10 and the other side's
Yep.
8.
Okay, you did trig in a nutshell, and while, yes, it was a very easy example, trig is really that in a nutshell. Here's what we notice in this particular case. 1, there was an angle here. Great. Did you know what it is? No, and you don't care necessarily what it is. What matters is the ratios. Okay? As such, if I just go back to those yellow numbers, and only those yellow numbers, how many combinations of those yellow numbers could we make? Nope, not infinite. Just, okay. 1, 2. How many different combinations are there?
3.
Arguably 3, or the other argument is 6. Why could you make an argument for 6? Because you just flip them, although that's the whole difference between basically these following things. Sine, cosine, tangent. All these are, listen, don't groan at me, it's really not that bad. These fancy words, I got messed up when I was in high school, and I thought, oh, there's some crazy math going on in a calculator. No, literally all this does is say, pick these sides. That's it, right? Hit me up with SOHCAHTOA. What sign? And, cosine? And tangent. Cool. You know what sides to pick, therefore you know exactly what sine, cosine, and tangent are. Meaning, without knowing any angles whatsoever, what is the sine of these triangles? Not hard.
6 over 5.
3 over
Sorry, 3 over 5.
3/5.
Yeah.
What's the cosine?
4/5.
What's the tangent? Congratulations, you guys know all of the math necessary to do sine, cosine, and tangent. That is it. All we know about this is this. If this angle is the same, what if I drew the triangle 10 times bigger? Would the ratios change? Meaning, if there is an angle, if you know one angle, then you should know every possible ratio. Do me a favor on your page right now. Use your protractor to draw an angle at 30 degrees and draw a line that's 10 centimeters along that distance. It'll take you like 2 minutes. Come on, we got some work to do. Draw an angle at 30 degrees and draw a line that is 10 centimeters long. So again, you're going to draw an angle of 30 degrees and then a line at 10 centimeters. Once you have done that, complete a triangle with the bottom being on the edges. And measure the length of those sides. Go. Pig box, it's over there. No, it's not over there. It's a pig box. Fair enough.
I don't know where they were at.
Gotcha. Seems like a decent question to ask at the beginning. All right. Now measure the length of these sides when you're done. Yeah, I need you to go fast too.
I'm gonna leave just between we go less fast.
I think that's actually true.
Oh my god. What?
It's when you guys get whinier, but it's not necessarily true. When I rush you guys should go faster.
I know.
All right, measure the length of those sides. If you haven't yet already, here's what you're gonna find.
It's not a threat.
Sort of is, but I don't care one way or the other.
Oh, I was going to draw like thank you. Why am I forgetting to do this?
You know, it's precluding you guys from going faster, having to commentary on the thing that you are currently doing, many of you.
No, it's not.
I am struggling. I need to talk about this out loud while I am struggling. I'm sure that no amount of my mental capability is hindered by the fact that I am talking about the struggle that I'm currently having. It's totally not a thing that's happening.
I got 8.5. I need that big.
All right. Now, certainly, okay, a little bit of error can happen on this because you drew your line a little off, or I drew my line a little bit off. I know where I'm getting my numbers specifically from. This is roughly what you should be looking at. So humor me real quick, then. What is the, based on what you literally just measured, what is the sine of that triangle? 0.5.
Yeah. 0.5. That's what it's.
Okay, and based on these, just based on these, because I know they could be a little bit off depending on what you put down. Okay, what is the cosine? Okay, and then what would the tangent be? You're probably going to need to use your calculator. I don't have this one off the top of my head either. 5 divided by 8.7 again.
0.57.
Cool.
Or 0.575.
Let's just go 0.57. Cool. Now, in your calculator, do me the following. Making sure that you're in degrees first. What does your calculator say the sine of 30 degrees is, the cosine of 30 degrees is, and the tangent of 30 degrees is? I gotta guess.
Well, tangents that cosine. What am I doing? That is tangent. Wait, I already. They all equal.
Sine is 0.5. It says that your cosine is 0.866 and then some decimals on that, and I'm pretty sure that it says the tangent is 0.563. I can't remember exactly the time, but something like this, yes? Okay, when I was younger, what I used to think is I used to think that the calculator was doing magic, crazy math when I punched in sine and cosine and tangent, and it isn't. All your calculator is doing is pulling off of the table. Before we ever had calculators, this was given to people doing trig. And if they had to find sine, what they would do is they would come over here to the angle. They would go, okay, well, what's my angle? My angle's 30. Okay, so I'm going to go down to 30. And then, so what's the sine? Well, the sine's 0.5. And what's the cosine? Well, it's 0.866. And what's the tangent? It's about 0.77 in that particular case. Point is, someone has gone out and has measured for every single angle for you what those ratios are. So the moment you have an angle, you have every possible ratio of a triangle always. Now all you need to know is one side. That's it in order to solve these particular problems. So what is going on here is that an angle gives you a ratio. That's it. That's all you got to know out of this. If there is an angle, there's a very specific ratio that goes with it. We know what all those are. That's what your calculator is doing when you punch in sine or cosine or whatever. Now, how are we going to use that in this class? Well, here's what we're going to do. We're going to use triangles in cases where straight up measurements are not going to be easy to do. Like later this year, we're going to go to Six Flags. So see fit to join us. And I would like to know the height of particular roller coasters in order to do the math. And sadly, over my many years of doing this, they have never let me climb 1 meter stick after another meter stick and just to see how tall that thing is. So dumb. But what they can do is this. I can go, hey, I need to figure out how tall the ceiling is in here. So I use a sextant, which is a fancy $10 word for a protractor with thing hanging on the end. And if I am looking down it, if I'm looking completely horizontal, where should the thing hang?
Down.
Where should this hang at then? At 90 degrees. So now what I can do is I can stand, say, at a very particular location, like back here, and I can like, okay, I want to find the height of the ceiling. So I line up the height of the ceiling with my eye. And I look here, and apparently it's hanging at about, oh, what is that? 77 degrees. So what does that mean? It's not a 90 anymore, it's a 77. So what? Angled how much? How much should I angle? 13 degrees. So the angle between my eye and the top of the ceiling is 13 degrees. The moment you have an angle, you have a ratio of every possible side. So I just measure a side that's easier to measure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, say and a half. It's 15 and a half feet to the wall. So what did I measure? Yeah. So here's what I have. I know that this side right here is 13 degrees. Okay? And I know that this side right down here is 15.5 feet. Because I have an angle, I know every possible ratio, or my calculator does. So all I need is the right one. What am I looking for? Well, I'm looking over here for what the height is in that particular case, right? So I know this side, I want that side, so what combination should I be using? Tangent, opposite and adjacent. So I come over here and I punch in tangent of 13 degrees. Now before we get too much further into this, I'm going to show you kind of the long way to understand this and the short way that you're usually going to do the math. First, if you'd hear me, type in tangent of 13 degrees into your calculator. What do you get? 0.230? 231. Okay. Now, it looks like one number. In truth, it's not. It's not one number. It is, in fact, a ratio. It's just that the top number is 0.231 and the bottom number is 1. What does that ratio say? For every 1 foot along the adjacent, the hypotenuse will rise about 23.1% of a foot upwards. So now all I need to know is how many feet I'm going this way. Or in other words, the tangent is equal to the opposite over 15 feet. This ratio is equal to that ratio. Or that's equal to that. And you can simply see I could just do some cross multiplication here. 1 times h, 0.231 times 15. Don't write this down because this is not how you're going to do it. Just humor me real quick. But somebody punch in, what is 15 times 0.231?
3.465.
Okay, so h is, what's it, 3.1?
465.
Let's go 4.7 then. But that doesn't make sense. So I just calculated the height of the room is 3.46 feet. Correct. Yeah, when you look at that triangle, I was measuring straight from here. So what is h in this particular case? Nope.
Your eye level to the ceiling.
That is from the eye to the ceiling. So what very simple measurement would you need now? My eye. So I'm roughly 5'6". Let's, for simplicity of math, we'll say my forehead is 6 inches tall. I don't think it is, but whatever. So 5 feet. All right. We're just going quick here, which means the actual height of the room is something like 8.47 feet. Does that seem relatively reasonable? Yeah, that actually is the height of the room. Now, here's how you are usually going to do these problems. I wanted to show you this because I want you to see this math right over here. But here's what you're usually going to do. One, you are going to set this up. But there's no reason to actually do the 0.231 right in here. What you're usually going to do instead is some really basic algebra. To get h by itself, I'm just going to multiply 15 on both sides, and you're going to get that h is equal to 15 feet times the tangent of 13 degrees, and punch that all into the calculator at the exact same time. Now, does that do the exact same thing? Yes, because once again, the tangent is telling you that every 1 foot of the adjacent, I'm going to go up 0.231 feet upwards, and since there are 15 feet on the adjacent, I should go upwards 0.231 15 times, and that's where I'm getting my 3.47, and then I would add 5 regardless. That's how your problems are going to look. How are we doing so far? Cool beans. Let's continue, because I'm not done. All right. Next, another couple of small things in your homework. Your homework uses a thing called minutes. They're not actually that difficult. They're not minutes like minutes on timeline-wise. They are actually a fraction of a degree. The way it will say it is it'll say something like, hey, the angle of this is 42 degrees and 30 minutes. Here's the simple thing that you got to know is a conversion to get that to a fraction. There are, and this sort of makes sense, 60 minutes in 1 degree. Okay? A minute is basically a way to tell the fraction. There's a reason why we do this in terms of the world, but there's a handful of these. So all you would do here is just this. You basically convert, okay, 30 minutes, there's 60 minutes in 1 degree. So I see that 30 minutes is 0.5 degrees. So all you would do is come back here and go, okay, well that means that's 42.5 degrees. Now continue with the problem entirely like normal. Okay, so you're going to have to convert minutes over degrees. Pretty simple stuff. Then continue like normal. Everyone cool? Cool, let's move on. When you guys do this quiz, you will not be using a calculator. Okay? The reason you're not going to be using a calculator is because I want you guys to know all of the ratios of the following triangles. So we need to know the basic triangles. There are 3 that we will use in here, 2 that you usually have probably used, and 1 more that you probably don't use quite as much. The side commentary makes it difficult for me to focus, and I imagine the people around you to focus as well. And quite frankly, given all of the stuff that I have down and how much work I put into preparing this for you, it a little bit pisses me off. Now, I try to be comical about it to a certain degree, but please do keep it. I'm not asking for it to, like, never happen. I'm asking for it to not always happen. That's how I feel too. All right, moving on. So let's start with this triangle right here. What does this one look like? Come on, you guys got triangles, right? Give me one. 45, 45, 90. Thank you. This is your 45. I'm not going to show the other one because you know it's the same thing. What are your ratios? 1, 1, root 2, yes. Okay, what's the next one that you commonly use? 30, 60, 90. Okay, small angle, big angle, 30, 60. I think usually when it's listed for you, they usually put 60 on the bottom left. It doesn't matter. You can draw it like this, or you can draw it like this. The thing you got to remember is small angles across from the small side. What is the small side? Do you not remember? It's okay. Small side is 1. Okay. Hypotenuse is 2, root 3. The one that you probably do not yet have is a little bit bigger than this. I'm going to say it it looks almost similar to a certain degree. I've actually already used it here today. And it is, instead of the angles being nice and clean, 45, 45, 90, 30, 60, 90, the sides are a little bit cleaner. And it is the 3, 4, 5 triangle. This angle right here, it's actually a bigger decimal that I'm going to give to you. It's 36.9, 53.1. When I do it on a quiz, though, I'm not even going to worry about the fraction. If I say, hey, what's the sine of a 37-degree triangle? You go, oh, 37. Okay, so what is the sine of a 37-degree triangle? 3/5. What is the cosine of 45? Oh, 45. Come on, guys, you can do this quick. It's not that hard. When I say, remember, sine, cosine, and tangent means pick the right side. 1/√2. And remember what I've said recently this year, I don't care about radical on the bottom. If you do, that's fine, but I do not. So you can leave it as 1/√2. What is the tangent of 60 degrees? Tangent? Just √3. You're √3/1. Yeah. Okay. You answered √3/2 would be the sine. That would be the sine of 60 degrees in that particular case. All right. So I think if I pretty quickly just said what's the sine, cosine, and tangent of an angle up here, you can obviously pick these down. You are welcome to write these down. These are definitely something as well that I would not preclude you from. So if ever on a test you didn't have them memorized or whatever, you could just ask. I'll throw them on the board. I don't care. But the reason why these angles are super nice is that we are now going to head down here to talk about the XY axis. And if you look at the first quadrant, those angles, 45, 30, 60, 37, and 53, kind of nicely break that up pretty evenly throughout that process if you turn them into triangles. Yes? Now, if I take a 45, 45, 90 triangle and put it over here, do the ratios change? No, but that's not a 45-degree triangle, right? What is it? Since you're in the second quadrant, what is it? 135, right? So 1/√2, the ratios would be exactly the same except for one major difference, and you already know what it is based on the quadrant it's in. What is the difference between the second quadrant and the first? The negative x. So that is what it is here. So if I asked you for what is the, say, sine of 135, it would just be 1/√2. It'd be the exact same as the sine of 45. But if I asked you for the cosine of 135, it would be? Yeah. So I would expect you guys to be able to do the following. I'm happy to help as much as I can on this, or you're welcome to work ahead of me on this if you need. I would expect you to be able to do what is the cosine of 217? Okay. What is the, let's go, sine of 300? And what is the tangent of 120? Oh, I'm sorry. No, not this one. No, this one. 315. My apologies. So to get you started, if you don't feel like you need me at all, please feel free to ignore me right now. Okay. All you're going to do at first is try to figure out which one of the original triangles this is. Like I said, for the quiz, you will not be using a calculator, but if you're not using a calculator, that means every triangle I give you will be one of these. Okay, and you can just do some usually relatively basic math and leave radicals unknown. So here you go 217. So what I would start off with is just draw an XY axis and go, okay, where's 217? Well, that's 0, that's 90, that's 180. How much do I have left over? 37. So that means 37 would go here, right? And now this is my triangle right here. 37 is opposite of a 53, which means that's the small angle, which means it's across from the small side. So that would be 3, 4, 5. And what's the difference between 37 and 217? Well, some of the sides are negative. What sides are negative? X and the y, so -3 and -4. So what would, if you have this picture, easy peasy, what is the cosine of 217? -4/5, yeah. Adjacent over hypotenuse. Okay, what about the sine of 315? One thing you will note, okay, there's 90, there's 180, there's 270. How much do I have left over? think I have 45 left over, which means this is a 45 degree. What I will always do is draw my line first. Now, what you will notice about all the triangles, and we'll talk about this in a couple days, all of the triangles have their base on the x. So you're never going to draw your triangle like this. You will always draw your triangle like that. And when you consider the angle, you can usually consider the angle the one between the x when thinking about your ratios, okay? Even though it is 315, which is over here. So what does that mean? Well, this is a 45, 45, 90, so 1, 1, root 2, okay? And since that's underneath, we have a negative y and a positive 1. So what is the sine of 315? Negative 1 over 2. Of course, if I'd asked for the cosine of 315, it would just be 1 over root 2 in this case. Finally, tangent of 120, similar to a conversation we had a second ago, that's 90. This is 30, but that's not what you're going to worry about. You're going to worry about the fact that that is 60. So that's root 3 over there, that's 1, and that's 2, except that's negative. So what would the tangent of 120 be? I think it's negative root 3, yes. Yeah. I would want you to probably simplify, obviously, the 1 on the bottom. That would be something that I would probably expect you to do in that particular case. How do we feel about this? I got like 2 other things to hit, and I'm running out of time. Okay, I'll probably have to finish this first thing tomorrow. I talked briefly earlier about the cotangent, the secant, and the cosecant. I don't know if you remember exactly me doing that. I didn't use those words directly. But when we were over here, I was talking about the fact how many combinations there are of this. And that's 3 to 5, 3 to 4, 4 to 5. Okay, basically, cosecant, secant, and cotangent are literally just the flips of this. Right? So we don't usually worry about them in here because they don't help us. This is all we really need because we can pick the sides the way that we want them. That being said, the opposite is true of the inverse sine, inverse cosine, and inverse tangent. Now, they're really not that bad, okay? All it is basically is simply this, okay? If you go back to this table, we kind of did it earlier, where if you go and you say, what's the sine of 30? Essentially what your calculator is going to do is go, hey, they just told me an angle. I'm going to tell them the ratio. The inverse sine is literally asking it to do the opposite. If I say, what is the inverse sine of 1/2? Well, then it's going to find the ratio first and go, oh, that angle is 30 degrees. That goes with it in that particular case. So to put that in perspective, you should be able to do this quickly with the simple triangles real fast here. I should be able to ask you, what is the inverse sine of 1/2? Well, you would go 1/2. The sine would be 30. What is the inverse cosine of 1/2? 60. What's the inverse tangent of 1? Inverse tangent of 1. 45 degrees. Last one I'll do. What is the inverse sine of 4/5? So I'm telling you the ratio. It's just the opposite of what I've been doing. If I say what's the sine of 60 degrees, you'd find 60 and go sine is that over that. If I said what's the inverse sine of 4/5, you would go, oh, 4/5, what would make that a sine would be 53 degrees. All right, we will finish this conversation first thing, actually maybe after the quiz tomorrow.